Welcome to lesson 10.2. We're going to work with diagramming data. We've got two different types of diagrams that we're going to focus on in the beginning, and then one additional diagram that we'll learn about at the end. There's a lot of important vocabulary that goes with these two different types. The first word is called a quartile. Basically, a quartile is something that divides the data into four equal groups, because that QUART, you'll often see that used as a quarter or something like that, something with fourths. So you would have three quartiles that would divide a set of data into a total of four equal groups. The middle quartile is the median for the whole set of data. So I just write my whole data set out and I look for the middle number. The lower quartile is the median of the data below the middle quartile, and the upper quartile is the median of the data above the middle quartile. Then we can use what's called a box and whisker diagram that would allow us to show the quartiles as well as the extremes or the end points of a set of data. It's a very easy way to just visualize relationships within a set of data. If you're looking at that, you can look at what's called the interquartile range. That's the difference between the upper quartile and the lower quartile. It allows you to see kind of more of a central tendency of a set of data. We also have stem and leaf diagrams, which you're probably more familiar with. That's the type where you show the leaf as the last digit in a number set, and the other numbers, it could be tens place, hundreds place, whatever it happens to be, those count as the stem. Let's practice. Okay, so I've got a set of data here. They represent pages read by 12 students in class. We're asked to find the lower quartile, the middle quartile, the upper quartile, and then draw a box and whisker plot. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sets of data. So between these two will be my middle quartile. So if I add those two up and divide by 2, I would get 39.5. And we'll put it up here to make it easier. This would represent my middle quartile. Then if I look to the left of this middle quartile, I have 1, 2, 3, 4, 5, 6 values over here to the left. So 1, 2, 3. So but these two I would need to average to find my lower quartile. That's easy. Add them up, divide by 2, and I would get 29.5. That will represent my lower quartile. And then there are also 6 on the high side. So these are my two. Add them up, divide by 2. This time I get 48. And that would represent my upper quartile. So we found all of our relevant points that we need in order to be able to draw our box and whisker graph. Okay. So what you'll do when you're creating this, your end points will be the ends of your data. So my end point down here would be a 16. And then my end point over here on my data would be a 70. You want to try your best to make this proportional, meaning kind of make it look like the right proportions. Don't put, like 25 here and 50 here. Try to make it look as reasonable as you can. So it looks something like this. Then I'm looking for my lower quartile, my middle quartile, and my upper quartile to graph those on my line here. So between 16 and 70, I'm going to say a little closer to 16 obviously is going to be my lower quartile. That would be 29.5. Okay. Then a little further down, I'm looking at 39.5. And a little further down from that, I'm looking at 48. See if I can level those out a little bit. And those three middle, lower, and upper quartile values will make the box. The endpoints make our whiskers. So this middle one, I would want to label 39.5, and the final one, 48. So you see, all that you need to do is to find your quartiles and put them on your box and whisker graph. Okay, let's do it again. This time it also asks me to calculate the interquartile range. So first thing, I look and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 data values, which means 1, 2, 3, 4, 5, 6. This will be my median. It will be my middle quartile. On this side, I have 1, 2, 3, 4, 5. So here will be my lower quartile. 1, 2, 3. Here will be my upper quartile. So when I go to create my box and whisker, start down here with 12. And then down here, I'm going to have 35. And then I have three numbers, 22, 28, and 32, that are going to have to go on my line here. If I look carefully, 32 is going to be kind of close down here to 35. 28 is going to be not too far from that. And then 22 is going to be just a little further. And remember, these go together to make my box. I just need to label them. So I have 22, 28, and 32. So here's my data that allows me to see my box and whisker for this data. Let's continue looking. Okay. Next, I'm asked to make a stem and leaf plot. Remember that the leaves are going to be represented by the last digit or the ones place. The stems are going to be, for this one, there's only 10, so they'll be the tens place. So when I do this, I don't even really need, I'm not going to put that one on this one, it makes it easier. So I have a tens place of 1, I have a tens place, so I have one number in the teens or tens, one number in the 20s, two numbers in the 20s, 1, 2, 3 numbers in the 30s, 3 numbers in the 40s, numbers in the 50s. I don't have anything in the 60s, so I don't have to put that there. Then I also have a number in the 70s. Okay, so now I put the leaves in the ones place of the teens number. I have a 6. In the twos place of the 20, I have 2 9s. In the 30s, I have a 0, a 5, and a 9. In the 40s, I have a 0, a 4, and a 6. 50s, I have a 0 and a 1. Then in the 60s, I have a 0. Those all represent my values for this stem and leaf plot. Also, what you'll see included a lot of times is a key that says 1, 6 equals 16. It's really just a way to explain to the reader how you've done your stem and leaf plot. Let's look at another one. This time, my values are not just ones and tens. Now I also have a hundreds place. So that means on the left, I'll have both the tens and the hundreds. And again, my stem will only be the ones. So I have 120s, 130s, 140s, 150s, and 160s. Make it easier to see. Then over here, I have 120, 125, and 129. I have 130. Oh, I have two 129s, excuse me. I have 134, 138. I have 143, another 143, 149, and another 149. Then I have 156 and 159 and 161. Again, I'll say my key is 1, 2, the 0 equals 120. And I'll just include that somewhere with my diagram. These tend to be a little easier and a little more familiar to you. The last type of diagram that we're going to talk about is called a scatter plot. The great thing about a scatter plot is that you've been doing a lot of this when you are graphing ordered pairs. So a scatter plot is just a graph where you have a huge set of ordered pairs and you graph them all in the same coordinate plane. Often you will see scatter plots that only include this first quadrant. Because remember, before we went like this and kept going and like this and kept going because here's our origin. This one only includes the positive y's and the positive x's. That's very common. We're asked to construct a scatter plot of the data relating the number of exercise minutes per day to a person's heart rate. Those seem to be the two things that we're comparing. So typically first in a table will be our independent variable. That goes on our x. And then the second will be our dependent variable, which goes on our y. So if I look, my values on my x go anywhere from 5 up to 60, it looks like, is my biggest value. So there we go with some values. I would also want to include a title for this. Now, you won't be able to see the title if I put it down on the bottom. So I'm going to put it over here on the right and draw an arrow. You should really put it down below the axis. And my title just tells me what this axis has on it. And so this is minutes of exercise daily. Okay. And again, you would put it down here. I've just run out of room down there at the bottom. Okay. Then up my y-axis, it looks like my values go from, they're all kind of in the 60s to 90s range, but I wouldn't just want to start there. However, if I'm going 60s to 90s, I could count by 10s, I could count by 20s. Let's count by 20s. We don't need these to be too exact. So 20, we're going to give some more room since we're counting by bigger intervals. 40, 60, 80, and 100. This is what's written down there, though I don't know that you can see it below the x-axis, but basically down here you would write 5, 10, 15, 20, all the way up to 65, I believe is how far I went on this one. Now I want to label this left axis. This says it represents my heart rate, or a person's heart rate. Okay. That would be my label for this axis. Now I'm going to graph my points. So I would want to graph the point 592. So 592 might be somewhere around here. Then 30, 75, maybe somewhere along there. Then 15, 78, 10, 90, 45, 70, 12, 88, 40, 70, 40, 74, 60, 68, 35, 76, 20, 76, 8, 78, and 25, 76. Then it says, what does this graph show? So if you were trying to look for a trend in the data, what it looks like as my numbers get bigger on my X, which means as my minutes of exercise daily gets bigger, the numbers on my Y are going down. I just use arrows to help me represent what's happening. Then in words, I say, as the minutes of exercise increase daily, maybe I should say minutes of daily exercise increase. That might be better. As the minutes increase, the heart rate decreases. If I look for what kind of trend I have, think about just drawing a line that kind of shows the general pattern here. Does that line have a positive slope or a negative slope? That would be my correlation. This one looks like it has a negative slope, so it has a negative correlation. Okay. All right. Again, most of your skills on graphing and making number lines that we used in Box and Whisker and graphing for scatter plots are skills that we've used before.